Going back to work after the weekend, and it's pretty safe to say that not many of us like getting up, especially if there's a cold wind or a touch of damp in the air. It's on such a morning that you really appreciate the comfort of the car. What a blessing it is to have your own transport and not have to queue for buses and trains. This is a special day for John Wallace, an up-and-coming executive who has to use his car quite a lot for business. So he's had a message from the local garage to say that his new Ford Classic has been delivered and that he can collect it. There's no doubt about it, the name Classic is well chosen, for the smooth lines and tasteful styling certainly give this motor eye appeal. But there's much more to it than that. It's not just good looks that account for its popularity. There are so many subtle points to consider. Comfort, for example. The average motorist spends about a month a year seated at the wheel, so it's essential to provide him with a comfortable seat, to give him an uninterrupted field of view, and positive acting, easily reached control. There's no doubt that great improvements have been made in the safety systems of the vehicle, but the disc brakes would be of little value if the foot pedal was inconveniently placed. The most vital link in the whole chain, however, is the point where all the controls are brought into effect, the contact patch of the tyre. Like a lot of motorists, John isn't particularly interested in this item. As long as there's a tyre at each corner and it looks as though it's got some air in it, what does it matter what they are? One thing is certain, any motorist would look pretty silly if he had to face this situation. We took John over to our laboratories to show him what improvements, if any, have been made in tyres. They look much the same as they always did, round and black. But let us show you one or two interesting developments which have recently taken place. Firstly, although they look the same, the basic materials have changed. A new polymer, or synthetic rubber, has been discovered, which is quite startling in its behavior. Notice the lack of bounce. Or, to be a little more technical, how this ball absorbs energy. If you'd like this translated into more practical terms, it means that a tyre made of this new compound will absorb more of the shocks itself. Add some air pressure, the normal suspension and damping system of the vehicle, and it all adds up to a much smoother ride. Then, of course, there's the tread pattern to consider. The shape of each element is designed to give positive grip, not only when the tyre is rolling straight ahead, when the road sees it like this, but also when it's being steered and cambered while cornering, when the contact patch can be seen to take full advantage of the cling qualities of the new polymer and the greater adhesion obtained from the tread pattern as the tyre distorts on cornering. Let us tell you some of the considerations that go into the design of a new tyre. The reason why the tread pattern is made of such complicated shapes. Onto the casing of man-made fibre are moulded the tread elements, which contain deep knife cuts. These cuts open when the tyre is under excess load or drag and act like squeegees. These clear the water from the road and produce dry road friction in wet weather conditions. The pattern itself is built up of a number of elements which are varied in size and staggered from rib to rib in order to reduce tyre noise and give you a quieter ride. Buffer bars are included to reduce rib movement when cornering. By keeping the pattern open in mud and slush, a better grip and better control is obtained. Now, here's an amazing development. Called an anti-wander rib and located on both shoulders of every Autoway tyre, this revolutionary feature prevents that unexpected drag on the steering wheel when you cross a white line, capsize, or any other road irregularity. Well, enough of all this high-flown theory. The point that really matters is, does it work? John was taken down to see the India test team at work on a special track where the first test is straight-ahead braking. The high coefficient of friction of the tread compound and the squeegee action of the knife cuts work together to reduce the wet stopping distance by 10%. Having seen how it can stop, the next step is to see if it will go. On the traction test, the old compound gave very serious wheel spin. The Autoway grips like a leech, even on our specially polished surface. Raised white lines on modern roads are only one of the many irregularities which can affect car control. This is where our research boys pulled one out of the bag. They designed these saw-toothed anti-wander ribs which make the tyre climb the ridge or groove without that nasty kick at the steering wheel. It was soon clear that on Autoway tyres, the road was no longer steering the car. But we took high-speed films at contact level to get definite proof that our backroom boys' theory is of real practical use to the motorist. The next test was to evaluate the handling qualities of the new tyre. The driver takes the car through a tight chicane at high speed. Changing rapidly from one lock to another is not an everyday occurrence, but it provides all the conditions needed for this part of the steering and cornering test program. The theory that there should be better car control was beginning to be proved. Even John was prepared to agree that the designers had come up with a winner. The next important point was to find out whether the cornering qualities of the new tyre were any better. Our standard cornering test was carried out on identical cars. This one, fitted with ordinary tyres, was driven into a 100-foot corner at 34.2 miles an hour, and this is what happened. The second car, fitted with Autoway tyres, was subjected to a series of tests where we gradually increased the approach speed to see if the new polymer, working in conjunction with the new tread pattern, would hold the road better and give the greater safety in wet weather conditions that our boffins claimed. We clocked this car at 38.6 miles an hour on the approach timer, and there was no sign of breakaway. For the man behind the wheel, this means 27% more safety. At India, we attach a great deal of importance to the fringe benefits of tyre quality, and so the new tyre was given an audition by our acoustic expert. The song of the Autoway was recorded on pave, tarmac and concrete, and on several types of vehicles for subsequent analysis in the laboratory. It's surprising how, on a long journey, the noise of the wind, engine, suspension, and tyres can combine to cause driver fatigue. To round off the experiment, we arranged for both cars to be driven at the same speed and braked in the wet, and the difference in stopping distances was measured over a wide speed range. The results of this test were immediately obvious and showed that the Autoway tyres give far greater grip in wet conditions. A correlation of all the tests carried out both in the laboratory, on machines, and on various cars and road surfaces showed an overall improvement of upwards of 20%. A chance to see the sort of thing that goes on in the technical department convinced our friend John that there was much more to tyre design than the average motorist realizes. Like a lot of motorists, he was completely unaware of the impact that this unseen but nevertheless dramatic breakthrough in polymer chemistry would have on the design and manufacture of his tyres. Here, for the first time, was a rubber with all the qualities the technicians needed to make a tyre that would be fully functional in all aspects. Matched to motorway motoring and today's hectic driving conditions, there will soon be thousands of motorists like John Wallace demanding the additional safety, the additional control, and the additional mileage built into every India Autoway.